All right, so we're starting out section 3.3 with a warm-up. So this is what we did yesterday. So I want you to actually do these first two problems. The second one is an old one, but we're getting ready to do our quarter final, so that will be good practice. So 3.3 is one-step inequalities using multiplication and division to solve. So not a whole lot different idea than yesterday, except for with multiplication and division. We solve these the same way we did an equation for the most part. This is 9 times x is less than 63. So to undo multiplication, we divide. So these cancel out and you get x has to be less than 9 times what is 63, or 63 divided by 9 is 7. So x has to be less than 7. So how do we graph that? Open circle at 7, pointing to the left. All right, again, I have 1/2 x, or this could have been written as x over 2 is less than 4. If it was this way, this is division, so to undo it, we would multiply by 2 on both sides, because 2 over 2 reduces to be 1. So we have x is less than 8. If you did it the other way, this would be 1/2 times x. So to undo a 1/2 times x, we multiply by 2 again. So this would still cancel out. X is less than 8. So either way, it's the same idea. So put an open dot again at 8. And everything less than that should work. If you want to check your answer, could you? Yeah, let's pick a number that's less than 8. I'm going to pick 0 because 0 is easy. So if I do 0 divided by 2, is that less than 4? Well, 0 divided by anything is 0, so 0 is less than 4. That checks. That means we should be good. How will these two answers be different? So x is greater than 1. That is an easy one. There's 1, everything greater than that. Negative x is greater than 1. What does that mean? So what we normally would do is I need to get rid of that negative, which is like a -1 times x, right? So to undo a -1 times x, I would divide by -1, and I would get x is greater than -1. So if I go over to -1, put an open circle, greater than, that would be this. Don't write this yet. Let's just talk this through. So let's try one and see if it works. We'll put it into our original thing. So I'm going to pick a number greater than -1. I'm going to pick 2. So I have negative, and I'm going to plug in 2. Is that greater than 1? -2. Is -2 greater than 1? Ooh, that doesn't work, right? So that means my arrow has to be pointing in the wrong direction. So this cannot be right. It means it has to be going this way, which means that I would have had to have this for an answer. X is less than -1. Now, what's going on here? There's a special rule. I think it's on the next page, so let's take a look. It says when you multiply or divide each side by a negative, you must flip the switch or reverse the inequality symbol to maintain a true statement. So for example, if it was less than, you'd change it to greater than. If it was greater than or equal, you would change it to less than or equal. So now let's try one using our rule. So again, this is m divided by -7. So to undo it, I'm going to multiply by -7. It says when you multiply or divide by a negative number, you have to flip your switch. So I'm going to have m. Those will cancel out. I'm going to flip this switch. And -7 times -6 is, -7 times 6 is -42. So m is less than -42. Could we check a number to see if it's right? Sure. Let's try, let's see. A number less than -42 is -49. That's smaller than -42. So let's try that. -49 over -7. Is that greater than 6? Negative 49 divided by negative 7 is positive 7. 7 is greater than 6, so it does work. So it means our inequality must be true. So this is my answer, and this is my check. All right, so let's try another one. Again, we're going to divide by negative 3. If I do that when I go to rewrite, I write x, flip my switch, it was less than or equals. I have to do greater than or equals. Negative, excuse me, 27 divided by negative 3 is negative 9. So x is greater than or equal to negative 9. I'm going to let you do this one. Do this on your own. Let's talk about the next one because this was a little bit of a problem on the last test. So when you can think of this problem as two ways. Either it's 2x divided by 3. So to undo the division, I can multiply by 3. And then excuse me, negative 2x. I still have negative 2x. I have it times 3 is less than 9. And this would have been over 3, so those two cancel out, right? So I have negative 2x is less than 9. So to solve this, to undo negative 2 times, I'm going to divide by negative 2. And I get x is, flip my switch, greater than negative 9 halves. Now I'm going to try it another way. We learned that we can undo this by multiplying by the reciprocal. So 3 over negative 2. Undoes it in one step. Multiply by 3 over negative 2. Because 3 over 3 reduces to be 1, negative 2 over negative 2 reduces to be 1, so I just have x, flip my switch because I did it multiply by negative, and I'd have 3 times 3, which is 9 over negative 2. So I get the same answer either way, it's just one step if I do it by the reciprocal versus 2 steps. So what are the solutions to this, and we're supposed to graph the solution? So another one, I have 2/5. X is greater than or equal to negative 4. So I want to multiply by the reciprocal. So I'm going to multiply by 5 over 2 on both sides. Sometimes we do this over 1 so we can remember this rule. So those again are going to cancel. I have X as, do I need to flip my switch this time? I multiply by a positive number. Right, I multiply by 5 halves. So I don't, my answer is going to be a negative number, but that's okay. I didn't multiply by a negative number, so I don't flip it. Negative 4 times 5 is negative 20 over 2 times 1, which is 2. So it reduces to be x is greater than or equal to negative 10. So let's give it a try. I'm going to pick a number greater than or equal to negative 10. I'm not going to pick negative 10. Actually, we could pick negative 10. Let's put it in there. So we have 2 over 5 times negative 10. Is that greater than or equal to negative 4? Well, that would be negative 20 over 5. Is that greater than or equal to negative 4? This is negative 4. So it is greater than or equal to negative 4. So there's my check to make sure it works. It says graph the solution also. So I'm going to extend this. If I want to graph x is greater than negative 10, I have to have negative 10 somewhere on here. I'll put 0 over here. X is greater than or equal to, solid dot, negative 10. So let's try one word problem and then you can do the next one. A student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend at most, there's my thing that I need, $50 for this project. What are the possible numbers of cases the club can buy? So let C equal number of cases. A student plans to buy food. A case of vegetables costs $10.68. So I know it's $10.68 per, which is multiplication, case. So for every case, it's going to be 1068. So I'm multiplying 1068 times C, the number of cases, and at most $50. So it has to be less than or equal to $50. I can't spend more than $50. I can only spend 50. So to undo this, I'm going to divide by $10.68 on both sides. And I'm pretty sure this is not going to be a beautiful number. $50 divided by $10.68 is cases would be less than or equal to 4.68. So 4.7 about. That's an estimate, but that's okay because we're not breaking cases up. So I have to actually write how many cases can I buy? Well, they're not going to let me buy 0.7 of a case. So in this case, I can only buy 4 cases or less. So that is my answer. I can buy 4 cases or less. I can't buy any more than 4. I could almost buy 5, but not quite. So I want you guys to do this second one, this problem 4. Let's just talk a little bit. You walk dogs in your neighborhood after school. $4.50, again, this word per, which is what we had last time. Dogs, how many dogs do you have to walk to earn at least? So at least, you want at least $75, you want $75 or more. You guys try to write an equation for this or any equality for this one. And that is it for this section.